privileges, but I have no time to debug it. So if it's okay for me to speak without video, that's completely fine with me, if you're fine. So my background in this area is actually like dating back to my earlier years in my career. Before coming to Google, I was like mainly working on our monitoring stack and some of also the performance tooling related stuff. Years later, back in 2000 and a couple of years ago, actually, like when I was working on the Go programming language, we decided to kind of like take a holistic approach when it comes to our instrumentation stack and like observability tools. So I really helped the team, and that's when I started to become more involved, especially in the instrumentation side of the things. I realized that some of the work we needed for the language is blocked by a team called Census at Google, which is the core instrumentation stack for like RPC systems that we have. And I eventually ended up going to that team and unblocking myself with the hopes that like going back to the Go team and like just continuing what I was supposed to do. But I eventually really liked the project. So we open sourced some parts of our instrumentation library that ended up being open Census. And that's how I got involved in the larger community. Most of my work was very, closed sourced before Go. And with Go, like I started to just kind of like contribute to the open source, but I think got more involved in the larger community with the helps of Go and open Census. And one thing that was interesting about that project was most of our customers or users, generally speaking, just didn't care about like one product or the other, right? Like we had a variety of customers using different like providers, APM companies, and so on. So we just wanted to actually like generate good data that is useful for a large number of companies out there, which also helped us to collaborate with the larger number of folks, and it was very rewarding in that sense. Like it was not just we were helping our users; it's also like we were helping other companies. So I was really happy. And right now, nowadays, I actually work on databases, but part of my work is still related to latency analysis because debuggability of storage layers is just very, it's like a hairy, field, and we always contribute with latency. And like my specific role also requires me to contribute to that side of the things. So that's me.
Well, thank you. And for those of us who have joined us, this is a fantastic opportunity for you to speak to the leading experts in their fields and to find out anything that you want to know. So keep the questions coming in, and no question is, I'm gonna say it now, no question is too in depth, no question is too simple. We will endeavor to do our best to get them answered. So I think if we start with you, Sheng, like the Skywalking 0.8 release came out really recently. Could you talk us through sort of what's new, what's exciting with the 8.0 release? Sorry.
Mm-hmm. Yeah, the first thing is about, actually that version is more about the integration to support other communities, because recently Skywalking is used in two cases mostly. It's agent-based, distributed tracing-based APM system, and the source mesh-based APM system. And in both, there are people deploying a very huge backend, Skywalking backend, to support like hundreds of billions traces every day. So they have a very big facility infrastructure, and they say, I didn't want to deploy other tools, maybe to make our operation too complex. So they want to say, I already have application already instrumented by the Prometheus. And if we want to support that kind of very huge, several thousands or tens of thousands instance of application, we need a huge Prometheus cluster too. And we don't want that. We want to that Skywalking can cover that case, and we don't need to change the codes. We just immigration all of the data to the Skywalking. And that's is pretty challenging actually. The Prometheus is time series, and they look at the data from different perspectives. They provide a complex query language to query all of that metrics. But Skywalking is more about the enterprise product. They are doing pre-calculation. They will calculate first and save the result directly. When you query, just have the result. So, but no matter how complex that, the community driving that. So we decided we could do that, and we have a Prometheus fetcher. Most likely how Prometheus works like the server, but we run in the cluster mode. So you can fetch the Prometheus metrics from different instance and then convert them to some kind of formats Skywalking could recognize, and then you can have that in the UI. So that basically provides you very convenient things. And the other thing about 8.0 is we begin to support customized UI in Grafana. And we all know that Grafana is a super cool UI system. But Skywalking has their own GraphQL, and we haven't ready to integrate into the whole Grafana ecosystem, because that's immigration we evaluated, but it's not that easy. So we change our UI first and to provide a configurable UI. So when users have their business metrics, something like how many orders in last minutes, and such metrics can collected through the Spring Sleuth or Prometheus, no matter you want, and that metrics could show up in the Skywalking too. So that's just the biggest things we did in the last release, I think.
So that's custom dashboarding?
Yeah, customized dashboarding. More of the metrics, the graph, the charts, you can customize that. Even the charts in the topology, you can customize that.
Wow. And so I think there's been a lot of conversation, especially when there's, around sort of microservices and the number of, traces that you collect, and how much people want to see into their services around clock drift. And Jaana, I know that you've tweeted about this recently in terms of what these strategies could be for clock drift in distributed tracing. And I'm interested to hear from you and from the three of you as to what you found in trying to solve these problems.
This is like a very complicated problem, and lots of people have, like, I think expectations. Their expectation from clocks are so much like, I mean, especially like, our users, as soon as they turn on distributed tracing, they start to kind of like rely too much on the timestamps, in my experience, without sort of like realizing that our clocks are not accurate. And clocks are not accurate in general, like between any machines, like even in the same machine, like you may have like different clock sources and so on. But as soon as we start to provide to give people like more visibility into like what's going on by distributed tracing, I think like they sort of like forget the fact that those timestamps are not really accurate. One of the difficulties is there's instrumentation, but there's not instrumentation all across. So people rely on the differences between distributed trace spans to sometimes like try to like estimate like the network latency and sort of thing. So they started to rely too much on the latency represented in the distributed traces, even though the clocks are not accurate. So those durations represented on the distributed traces are not accurate. One thing that they came up as some of part of like some of the conversations that I was having in the last couple of years was, what can we do is like probably not to do much, because we don't have like much of a control over like the sources of the clocks, and so on and so on. But at least we may try to do provide some visibility in terms of, for example, at Google, we have a very interesting time API. It's called TrueTime, and it's explained in some of our white papers again and again. So at Google, if you ask time from TrueTime, it returns you an interval rather than the current timestamp, because it already acknowledges the fact that like we don't necessarily know what the time is, but it estimates it would be somewhere between here and there. So you can actually rely that like you are somewhere in between the interval. And my idea was like, hey, can we just use this when we're instrumenting things? So like rather than like exposing user like this event actually happened here, we give them a buffer. It might have happened here or there. So they always like, especially if you visualize it, they will be able to uh, recognize the problem, recognize that there's clock drift, the instrumentation data is not accurate all the time, and they can't rely on the differentiation between durations to calculate like network and latency and so on. At least they will be able to acknowledge. So that was the initial idea. People thought that I think it's more involved than that simple thing, but that's my initial idea, at least to improve the visualization so people acknowledge the problem.
No, that's great. And we've actually had a question come in for Adrian based on that as well. And, does Zipkin have any strategies for clock drift between instrumented services with a trace?
Yeah, but sure. That's an interesting thing about the, actually, it's interesting because when Jaana was talking, I was thinking about one of the related problems is that when people are navigating through different sources, right, they have different granularity of timing, and like logs, if you have a different timestamp, even if your trace is more correct, if another one doesn't have exactly the same one, it can be. So and this kind of leads into your question, what sorts of things? Like the first thing we did was basically just copy paste what Twitter was already doing, which was effectively a query time, sort of stretching out the graph, if you will, to make it look less weird. So for example, if it would basically just split the difference and then assume that a parent should never be able to be born before it should, the parent-child relationships, using the structural data to make it look less strange. Probably other systems might do that if they're presenting a trace graph, because sometimes the actual distance is, as far as people interpreting that as latency, is the important thing. But the other thing is in understanding the actual call graph, and if something is on the wrong side of the screen, that can actually have more severe effects in cognition, I think. And so it's kind of a dumb thing, but we do that. One thing we haven't done is and for years we sort of talked about it, which is sort of a bug view of the trace, showing all the things that look off to us, meaning that where's the small data wrong or moved, or where we're lost a parent and blah, blah, blah. And I would say clock drift is in that classification of adjustments where you sort of just adjust where you can. How do we reduce the data problem though? So we don't try to use any custom clock source or things like that. So the general question that we have is from folks, it would be to just try your best to use even old services that used to exist, NTP or whatever, to try to get your host clocks as close as you can. Now, the question about instrumentation, and that's a fancy word for the driver inside of your app that's collecting data. So that part, we have something very specific, and that was really kind of, at least in the Java space, we had to do some funny things, because what was happening was we would have drift in the same trace, and not only in the same trace, but the same part of it. By the time the request moved from one side of the process to the other, the clock would change. And so you would have things like negative durations and weird things. And so what we do, and I think a lot of other libraries do this now, but you effectively will pin the clock at the entry point into the process, and then just use relative monatomic time after that. And that means that even if the logs might be slightly messed for that specific request and what we call a local root, the fragment that is in that process, it's better, because at least as Jaana said, people over rely on timestamps for guessing things, and at least within the process, using monatomic time, it would be better. And so if they're trying to say did something happen before the other one or not, and you can't tell because they're all peers, you at least know. I mean, you have a better answer. It won't be correct, but it will be less incorrect. And so that's one thing that we do. And that came out of a use case from Samsung Smart Things, which is like an IoT thing. And they were having these things where like they're trying to debug some highly parallel stuff, and it's just harder to do unless you can freeze something. And so we just freeze the clock for that point where it hits, which we call the local root, until everything else exits. They all use the same clock tick.
This is really relevant to what we were trying to do, but we couldn't do as much as that you did by relying on the same initial point and only increasing from that, like by implementing your own monotonic clock basically in this same process. What we ended up doing is that at least in the span, we always like rely on the monotonic clock to calculate the duration. But the next time that you are creating a span, you are still relying on the wall clock. So there's all this like, in the same process, as you mentioned, there's all this like funny these situations. If we have time, I actually want to follow up with a question to you. You mentioned that you did some fixing. So like a child never shows up before the parent. In my experience, I realized that like people realize that there's clock drift and they're suffering from that by seeing it themselves. Like I've seen customers like looking at the distributed trace and realizing for the first time that like a child is happening from the parent. How is that possible? And then they immediately realize that there is a clock drift. And that's when I decided like, hey, we shouldn't do something about this maybe in the visualization, because it actually helps them to realize what's going on. So that was interesting to hear that like you went the other way.
Yeah, it's just the imperfection of optimizations, right? So like people who have no idea about the sense of clock drift, you have to bring like a lot of things to that table before it would be understandable, and especially with like a like a mobile thing or whatever with the minutes difference. But I would say that's also the second half of it was like what is the sort of like bug we created in that, which is that it would be nice. We haven't done it, right? But it could be done to have like the buggy view, and where it shows like, okay, here are the things, here's the real, so that and maybe some hints, like some annotations, like lines are a bit fuzzy or something like that, to just hint people that things, including clock and also like missing parents, that are sort of like estimated to be put into a spot. Because you're right, especially the more technical folks will notice that, and currently we don't have the best experience. So that means is that like if there's a question, we just say like click on the JSON, it has the authoritative data. The first Zipkin wouldn't even let you do that. So what happened was in the like circa 2015 one, all of that logic was happening server side. So the browser could never even present that. So one of the reasons why we switched, I mean, just there's a technical reason too. Like it's easier to just do this stuff in JavaScript, but one of the biggest problems was that people could have no participation in whether or not they're seeing the real data or not. So we had to actually create a special query called like raw back in the day to just stop it from doing that, for the exact reasons you're mentioning, which is that like people couldn't even know in any way. So now it's sort of like it's still under the rug, but you can lift up the rug by hitting the JSON button. And the next step from that logically would be to just say, okay, well, here's what it looks like. Enjoy.
No, that's great. We've had some really good questions coming in. So we're going to take a look at some of these as well. So let's start with this one. Don't forget, attendees, you can upvote questions as well. If someone's asked a question that you really want a response to, hit the thumbs up and it will push it straight to the top of our queue so we can get to it super quickly. So this question is, can you discuss push versus pull in telemetry collection? Who would like to take that one?
We all have.
It's where is the push and pulling happening, right? Like, I think that's a funny way to answer, but like there's always push and pull. Like, but where is the push and pull happening, right? So, like inside the instrumentation, it's always pushing. And then
I think this
go ahead.
question might be related to the Prometheus's pull
Prometheus,
model
yeah.
versus
Yeah, the out of
push
process
models.
scraping. Yeah.
Yeah,
Okay.
yeah, exactly.
Yeah. Fair
I
enough.
think
So
the
I have,
pool model only
yeah,
works for the metrics like Prometheus did. It's typically when you just want to sample the results, and the pool model may be a better choice. But we also facing the limitation when we look at the service mesh, the Istio telemetry v2, we notice that we cannot have the endpoint metrics because they are using they're adapting to the Prometheus pool mode. So when you use pool mode, and the thing is you cannot store too many things locally. That will burn your application. So that's basically you want to trade off.
there is also like some history behind this actually, like especially if this question is related to Borgman, maybe I can explain. So Prometheus, if the question is related to Prometheus, I can explain the history of Borgman because they took the model from Borgman. At Google, before we have a globally available monitoring collection system, there was this thing called Borgman. So you as a team would take it, run it. It was very similar to Prometheus. It would scrape an endpoint and just basically aggregate things. It had an alerting system very similar. So it was very similar to what Prometheus is currently doing. But as we are switching, so in this model, I think the compromise of having pull versus push was not that visible. Um, there are many reasons. There are many reasons. But when we were actually like switching to the global distributed service, we actually decided to take a look like what's going on. One of the main reasons that we decided to go with push is, it's not really good to go to a service if it's already overwhelmed with some incoming traffic or something, right? Like if you want to scrape, if you want to just scrape by creating a request to the metrics endpoint, and if the service is already overwhelmed with some like incoming traffic, it's not really good. In our case, it just makes so much more sense for services to push their data when they're available. So by using the push, you're basically giving them the opportunity to wait until they can push some data out of the service. And when we were like switching to Monarch, our new system, we pretty much like just decided to switch to push model, because now we have a service that is globally available, and push is always going to be available as soon as that service is available. So pool just didn't really make sense anymore, and it's a better model because the service can determine what time is the best time to push data out of the process. So we are using push model right now, but I think Prometheus is using pull model because it's based on Borgman, and they just wanted to maintain, I think, the deployment model of something like Prometheus versus a globally distributed and very highly available monitoring system is very different. That's all I know about this topic, at least in the historical context.
No, thank you. We've got so many good questions coming in through many channels, and I'm very, very aware of the fact that this is an hour. This isn't a long time. So I'm gonna go to this one, which has been upvoted, which is for either Adrian or Jaana. So many different instrumentations are projects involving tracing, but what exactly is the difference between open tracing, open census, and open telemetry? How did these relate to tracing ecosystems like Zipkin?
Who wants to take it?
Adrian, you want to start? You have more historical context on this.
Yeah, Andrew, it's great for you, not for me.
Great. Okay, so all all right, so in 2015, when the Zipkin community came together, we named it Open Zipkin because it was like not run by Twitter anymore. And our first gathering was actually in about July of 2015, and we went to like a site who incidentally had stopped using Zipkin, and we wanted to basically go around the table, figure out what all the problems were, aggregate community, and center it on that. So like the first like time that in the tracing that I was aware of people using the open thing was sort of like Open Zipkin, but it's no longer like we're not in the like list of opens anymore. Anyway, so we had some working groups, and at some point in time, there were towards the end, I think it was the end of 2015, there was a project discussed that like everybody decided was a real problem, which is like context propagation wasn't well solved, and it certainly wasn't solved uniformly. And what do I mean by that? I mean like so trace data that gets into the thing to analyze is sort of like what you would have these like push-pull discussions and scraping or not. That's the collected details, like the latency information, blah, blah, blah. The contextual parameters that allow all of this data to be related together in a tree in that's sent by headers and stuff. And so that's the context propagation. And so basically when things break, it's usually in this area, I mean, and also clocks. So there was a project called like distributed trace context propagation or something like that. And then, so we had started that in like July, and then another meeting or two, and it was like, okay, like some folks were interested in that. One vendor called Lightstep, I think they weren't even called that at the time. They had been in stealth or something. And then Yuri, aka Uber. And so we went on holidays. Came back, and all of a sudden there's this thing, open tracing. It's like, whoa, what happened? So anyway, you look and it's like rename. so it was renamed, and so in early 2016, this project has been like rescoped as sort of like a instrumentation library interface with an initial target to be 1.0 by I think February that same year. So it's quite ambitious. I didn't have them. And so at the beginning, actually the Zipkin community were designing most of the things. So Yuri at Uber was still actually running Zipkin, I think. And the other folks like our Cassandra lead, they had designed the first version of the Java interfaces, and different people were designing things. So I think maybe Lightstep were focused on the Go side, and then Yuri was doing the Python. So it's just like general collaboration. The scope started to change, and it started to sort of like scare off the Zipkin community, because it was like, okay, this is also logging, by the way. And so we were like, no way, we do not want people to start funneling their logs into the tracing system. And so over time, Zipkin distanced it from that because it would have just overloaded and put data in the wrong spot. And so that project continued. Even now, people are starting to talk about it, even though it's sunset. There was like kind of like a break where things were working. Like Uber formalized that they were going to work on a fork, called Jaeger, and blah 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 happened. And so effectively it became like, okay, you have community instrumentation, or you have things that are branded as open tracing, which usually work with Jaeger. And but some of them would work with other systems too, not usually, but like, for example, the Zipkin tracer for Java and open tracing is actually the most popular open tracing trace that there is. So these things are like about the library you would collect data with, but it has zero opinion on anything about like the headers used or the data format. I was much more excited in like the stuff happening. So Google started a project called Google Instrumentation Java, which is like an awesome engineer's name. So I was working with that group because I thought that the engineering was far better. I like the idea that you'd know what sort of stuff would be, you know, how the sausage is made, if you will. And that's like alongside a large ecosystem in Zipkin. So we basically didn't pick favorites. So like Yelp would do the Python thing, and we had first party repositories for different things. But like this project, I guess some manager or something decided that Google Instrumentation Java is not a good name. And so that was renamed to like Census or Open Census rather, which would be similar to like how Twitter's Zipkin became Open Zipkin, because it was formerly like the idea was that this was technology and ideas, and maybe not exactly the same code, but like the same principles of development. And so Open Census became like, you know, an alternative full scope, and it would reduce the amount of problems you'd have. Like, so for example, one of the problems with open tracing is you had no idea the performance attributes of the actual implementation, because everything was up for grabs. Like it could write data into the trash can, it could do anything, and so you had no idea the format of the data or anything. Whereas Census was more opinionated, and so it used like protoblock data definitions for like how the data would be shaped as it sends out, really simplify the exporter model. So for example, as people normally when they're doing metrics collection would know like here's the various shapes, and so that's how you can see like some metrics tools, like in Java there's something called Micrometer, which has like a billion backends. It's because they really did a good job of saying like here's the only responsibility you need to do. You need to like export the data, and so it's very easy. And so I really like that approach. So that project was going on. I was kind of like funny, like why is nobody at Google talking about this project? And it's like all these things are being marketed, and like, don't you feel like this is gonna not help you? And then all of a sudden I see this person, Jaana, like daring to write content on her blog about like census and stuff, and I'm like, wow, somebody's actually daring to speak up, and like we exist. So I was quite excited. I was a big fan, and still I'm a fan of Census. It's actually a well-used library. It's still going actually. So for example, Netflix is a Zipkin site as we classify things, but like as real life is it's like in different categories you're going to have different like leaders, right? So for example, the Open Census node library is you know, frankly, it's better than the Zipkin.js at the moment. I'll be honest about that. And so for their site, they use the Java Brave library. It's got longer history, it's stable, all that stuff. And then in their own site, they also use Open Census for the node, and yet they still use the same Zipkin format, because now that you're using like Census or this, or even Jaeger can spit out the same format. And so that was like the most important thing for them, was to be able to process the data. Like sometimes people forget about it, but it's like at some point you need to actually process this information. So basically at some point, I guess there's like this like, you know, CNCF, which is like a foundation for logos. And inside of there's software also. So at that point, I think Jaeger and Open Tracing were like formalized projects. Open Census was not. Okay, so what happens next? And so I think there is an idea that like, okay, this landscape is a little bit too complicated, and we have Census. And by the way, Census also does metrics. So the funny thing is that people, when they talk about tracing, sometimes they talk about like tracing first. Like they try to collect everything as like request traces, and then derive metrics out of that, like latency, histograms, blah, blah, blah. But there's other things going on in the process too, right? So like things are coming up and down. There's other types of metrics that are not request based, blah, blah, blah. So like that was another reason why I like Census. I was like, okay, well, somebody's paid attention about these relationships. Maybe the dimensions can match up. Awesome. So anyway, that same basic design principles were what was, I believe, because I'm not actually a part, I don't identify open telemetry, but basically it's basically the scope is very similar, much more similar to Open Census than it is about Open Tracing. Like, yes, there's an API, and Census I think was more like technically like classes and things, but but at the end of the day, I think everybody's going to use the same implementation, at least now, while things are like finding their way. The other thing that changed at least for Java users, and I'm not sure about the other programming languages, but formerly like open tracing and open census were very much like you configure everything. Whereas in open telemetry, at least the Java side seems to be like fully like agent, like how Skywalking agent would just like turn on the tracing button, and so more biased towards the automatic tracing. So in fact, in the Java, I think 100% of the instrumentation are actually in the agent bucket, and I don't see any instrumentation outside of that bucket. And the only other thing that's relevant, and I know this is a fire hose, right? But we have, I think, Open Census, similar to how Zipkin has a bridge into the Open Tracing API. Open Telemetry has a bridge for the Open Tracing API, similar to how like you can run the Java Zipkin library and then choose to use Open Tracing API on top of that by a bridge. That same type of bridge model exists. So if people are on the Open Telemetry side. So if people are using that stuff, they could use that existing code to the degree they have it.
It sounds like they've all got very specific use cases as well, and that they've all got their own kind of way that they can be used. And so with that, I'm going to jump to Sheng for a couple of questions about the use cases surrounding skywalking. So the question that we've had is skywalking mostly used for discovery service dependencies and profiling? Can you talk to us a little bit about that?
Yeah, that's the thing. Depends on how you are understanding all of the distributed system. So basically, we are very interested, or I think everyone, especially for the boss, they are very interested about the topology. That's why the skywalking trace is different from the Jaeger Zipkin formats. That's why we want to identify the service dependency, including the instance dependency and endpoint dependency. We want to identify that first, so you can locate the issue. Even from the beginning, all the people ask, well, I want to 100% sampling, and the people cost a lot of money. Even skywalking could support that in technical way, but still you must cost a lot of VMs to support that kind of billions of the traces. No matter how cool the technology is, this rule is about you need topology and the metrics to identify the boundaries where the issue happens. And then you have two options. One way you have the tracing. So you have the tracing to find the detail as much as possible. But still, like the article I and Adrian wrote about profiling, about you cannot get all of the details by the tracing, because that is not practical. That will burn your application. Too many spans, too many logs, too many tags, that will break the things. And that's the thing. I think there is a lot of presentation or speak about the tracing, about even the open tracing represent, they misguide people. Sometimes tracing is not doing that well. Tracing is payload. So profiling is an alternative way. So you can profile the method just in very limited scope, and then you can have the method performance. So that's why I think that question basically makes sense, that from the top and to the details. So basically you can have the service dependency, and then step by step, you will run into the profile way. But I will say not all of the issues need to go into the profile. You will even find the issue, by I say 90% of issue will be stopped at the tracing, and maybe 50 or 60 issue can be located by the metrics level. That should be fine. So let's say we don't say tracing is all of the result or the key result to anything to resolve any problem. That's not the case. We hope that people don't jump into that hole.
And is there going to be a plan for an exporter for skywalking to Zipkin in the near future?
Oh, I hope. I hope. Yeah, that seems asked many times for the Zipkin to skywalking or to skywalking to Zipkin, because both of them are used in different case. And some Zipkin user says, I want to metrics, I want to topology, I want to alarm, so I want to skywalking backend. And the alternative, there is a user use the Zipkin and they want to do instrumentation, especially in Java. Skywalking did a very huge field, covered a lot of plugins, a lot of libraries. So basically the good news is with the Skywalking 8.0, the module, the data module has been not such complex as before. So I would say if someone willing to spend time, there was maybe 3 weeks, we can have a Zipkin plugin for the Skywalking Java agent. And then you can shift all of the Skywalking's trace to the Zipkin backends directly. That technically is possible and is much easier than before. So, but the thing is, yeah, but the thing is, like I said, most of the maintainer contributors of the Skywalking is in China, but they need AM rather than just the tracing.
Fantastic.
So and we need someone. I need someone to volunteer, want to take such.
So get involved, people. Come and join us. Come and get involved in the community.
People ask about yeah, that seems not such complex. People always thought they are not familiar with the agent technology, but actually, when you do the Skywalking to Zipkin, you don't require, you don't need to have the capability of developing an agent, because that things have already to keep in the box of the Skywalking core. So you just need some basic Java technology skills, and you're familiar with the Zipkin model data, and we can do that.
Brilliant. So I'm very cautious. We do not have a lot of time left. So we're going to try and treat this like a quick fire round to get as much as possible to get some answers to these questions. So Isaac has asked us a couple of general questions about observability. How do you think about dealing with a general tendency for more metrics to be exported than are actually read for dashboarding, performance analysis, etc.? And secondly, observability systems themselves need observability. So what are some of the ways these systems can be monitored without being dependent on themselves? And we've got 7 minutes until the end of our AMA. So let's see what we can do.
Okay, 30 seconds on the monitoring and monitoring. So, so the good news is, like, for example, if you're talking about Zipkin, right? It does not have a metrics component, so we don't have this like conflict, right? So we have like we use metrics.
I can give an answer. I was just like reading the question again. How do you think about dealing with a general tendency for metrics to be exported and actually read for dashboarding? So this is actually a really good thing. And there was another question about like how do we scale monitoring in metric collection, and I can explain. So one of the reasons that Adrian didn't mention behind the reason that we started Open Census was there was not a single metric collection library that allowed us to do dynamically, enabling collection in the libraries. So at Google, we have a tendency not to like enable a lot of like metrics until we need them. We have all this like instrumentation already in the place. But they're like sort of like a no operation type of thing. And as soon as like we don't need those additional metrics, we don't enable them. All the metrics we collect are like the metrics that we care about for, SLAs, SLOs, that sort of things. But if you are having a difficulty or like a latency issue, or you want to debug a problem, there's like so much more instrumentation that is left in the, the RPC stack for you to be able to enable things at a later time. That was like one of the reasons that we were able to just go and like navigate the problem, enable, additional collection in a single machine or like a cluster machine or a specific service, rather than always collecting all the data all the time. So that really helped us to, reduce the outbound traffic in terms of like metrics data. Also, it allows us to like reduce the cost of like instrumenting things, because if you're not like collecting this data, it's basically a no op, so it doesn't like have any additional cost in the critical path of an RPC, for example. I can give you some examples of what type of like metrics that we collect in an RPC. We collect like the latency, which is the obvious one. We always export it. We always export the error counts, but there is the payload sizes. Some internal like messaging sizes, like the pay if it's a streaming for each incoming message, you can like instrument a bunch of different things. So we collect all these like different stuff, but we never export them. And at Google, you have this dashboard. You can go to it and select a service and just write a script to enable collection of one particular metric at a later time in production. So people end up usually doing like, if there's a problem, they pick a canary, they just go and enable. If they see any interesting data is coming, they are looking at data. Otherwise, they would just like turn it off. So that's kind of like very useful for us. And we don't have to like export everything all the time. We just like can kind of like depend on what we wanna, we can like enable things at a later time. And
I'm
open
so
census,
sorry to interrupt just very quickly. If you do want to continue for like another 5-10 minutes, we are more than happy to, so we can get through more questions, look at things in a little bit more depth. It's entirely up to you, because we are coming so close to the end of time, and we have got some really brilliant questions. So are you open and willing to stay for a little bit longer?
I'm happy. By the way, I can wrap this up. Like, I think this probably answers the question, at least like the first part of it.
Amazing, thank you. I'm so sorry to interrupt.
No problem. There's another part if you want to answer, which is like the observability for observability. We basically, I can actually give a simple answer to that, like not to explain the whole story and so on. We have been experimenting with some ideas, for example, a monitoring system is like always expecting some data, and if we see a difference in the pattern, and if it's not related to the traffic and so on, we actually want to like automatically generate some alerts. So like, this is more of like an anomaly detection type of thing on the observability data. So we will be able to ping people saying there's like something wrong going on, like we're not collecting as much as data that we are expecting us. And there's like more typical monitoring solutions that can check we can rely on the SLOs and so on. But on top of that, we also want to do some anomaly detection to see if there's any difference in the data we're collecting.
And so we've got another question for you as well, Jaana, which is, how on earth do you store it? How do you store these massive amounts of data?
It's actually like people think that it's a lot of data, and it's a lot of data, but I didn't mention when I was talking about open census, but Google's instrumentation stack for monitoring is really based on aggregating things on the fly. For example, we're aggregating metrics in the client libraries. Open census metrics library does aggregation in the process as much as it possibly. So rather than like exporting every data point, we aggregate things. That's one thing. Outside of the process at Google, there's all this like stuff that called delta aggregators. So on the same machine, for example, you run a process, sort of like an agent that takes all that data and aggregates again. And we end up like doing like multiple layers of aggregation when it actually hits the storage engine. And engine is like some sort of like a time series database. We also like have like hard limits in terms of like cardinality. If you want to like tag label the data, we have like a very we have hard limits around those. The dynamic so reducing the cardinality, aggregating things all around. And the other thing that I mentioned, like the dynamically being able to enable and disable things, is really helping us, because we don't have to collect all the things all the time. We can just go and like specifically collect things when we need them. There's a very good talk from George Talbot about Monarch. Monarch is the system that we use. So you can actually take a look. If you search for it, Monarch, George Talbot, probably it's going to appear. I can type the name. I'm not sure if I'm pronouncing it correctly.
Thank you. And so we'll take a look at another question that's come in here, which we've got so many. So we're going to do one more, and then I think we'll have to call it a day. Unfortunately, we will try and get to these questions in a different format, but thank you all for submitting some truly fantastic ones. So let's make this a good last question. How does non-RPC tracing work if I want to trace a customer-initiated workflow?
So I'm going to assume this is messaging. So one of the things that I think is very interesting is that, like, a lot of times the non-RPC, which is usually messaging, is sort of like the next thing to do. Because the RPC frameworks are easier to like strangle, and it's actually so basically, if you think about messaging, it's really core to like all the fancy things, right? That's how lambdas get activated. Like that's how things get pushed into these streaming workflows. So messaging is basically the other in main service communication. And so I would say that in this case, the start is very similar to how RPC would work. So some consumer operation is acting on the message. The only thing that's different is that because the message is also data, it's not necessarily going to be processed. Usually we end up having to like push things into the message somehow, so that if it's later processed in a different queue or whatever else like that, it could be resumed. And that stuff is more dodgy, I would say, than these like handoffs that usually exist in RPC frameworks, which have ways to propagate, more straightforward like. And the other thing that messaging traces can give you a new challenge is the length of the trace. It's very hard for a producer of a message to understand all of the knock-on effects of that. So for example, we've had folks in Zipkin asking us for like trace breaker functionality, like, and there's some hints of this model inside of Census, like the link structure. But how do you keep the flow going without something being like a million spans? Because a message could just be a clock tick, or it could be like this massive workflow. And because everything's decoupled by nature, it's one of the hardest parts of tracing.
Thank you. And I said that was the last question. I lied. I can't resist. So what's possible with retroactive tracing? Is that a possibility?
So retroactive tracing is, as far as I can understand, being able to enable tracing at a later time, the call chain. In tracing, we need to downsample because, if we have to sample all the requests, it would mean we have to collect a lot of data. And also tracing is expensive, so it will mean that it's just going to be more costly. Retroactive tracing is this concept that if you realize that something really interesting happened all the way down, like, in the call chain, even if you haven't sampled that particular chain, you realize that, oh, this is very interesting and we should collect it. So you decide that we need to, enable collection at this point and propagate this decision back all the way. So, the parents can also collect some data, even though, they were not sampled and didn't started collecting when the call has started. So it is really interesting because tracing, like most of the time, if you take a look at the traces, like they look very similar. But from a user, what I really care is like, hey, if there's like an error or if there's like a really like 99th percentile type of case, I really want to see a trace of that particular thing. With our current like sampling approaches, it's just not really, easy to capture all of these cases. So the retroactive tracing is just kind of like allowing you to capture interesting things and at least like partially collect the traces. So you as a user like just going through, the tracing data and can really see all these like 99 percentile situations and have enough data to be able to debug what actually happened.
No, that's great. Thank you. And again, I know we're like a little bit over time. If you are happy to stay, then we can keep going. If you do have other places, other engagements, we do completely understand. But if you are happy to carry on, we can carry on as well.
I'd say a close buddy to retroactive tracing is cheap tracing. So like for example, like one of the things we've had for a couple of years chat on with Zipkin is how do people get 1 hour of data super cheap, like no indexing except for trace ID, blah blah blah, stuff like that, because it's effectively giving the same thing, and it would work across messaging or one-way scenarios too. But it's still not cheap. Like it's not cheap in the process. You still have to decide, and it's surges is still going to give a wild card there. But I would say that's a close buddy to retroactive. So a secondary storage that only has an hour, and then the rest of the normal sample goes someplace else.
Mm-hmm, mm-hmm.
Yeah,
Brilliant.
Speaking of the retroactive or later sampling, the most challenging when we facing a highly distributed system, the case will be based on the queue system. The message queue system will make the later decision much harder because there was no response for the original caller. And then you downstream already make the decision, then you only have the part of the trace. You kind of have the wall. But today at least.
By the way, sorry, I didn't want to interrupt. I wonder if you have ever seen this idea actually implemented. Like, I only know it as kind of like a rough like concept, like other than Zipkin, like I haven't seen it actually myself. I used to believe that that's just a concept.
Yeah, in Skywalker, we didn't implement that either. But we have some later decision about profiling, because profiling just happens in the process only.
Mm-hmm.
There's that like Z-trace, right? So the manual stitching and the tracing together. I think Census had like a Z-trace special HTTP endpoint, and you could like kind of like look, see if the trace is still inside there. So it wasn't really like terribly intentional. But like the only thing, like I wouldn't say like retroactive, I haven't seen that implemented, but definitely variants of the cheap trace, definitely. Like Netflix one, they have like a secondary sampling header that they use that would go across, and then would have like the same way that you'd have experiment IDs for your apps and like feature flags, basically, that you could have certain parts of the network that would actually collect more. So it wouldn't be retroactive though, because like it would just be more reactive. Like Yelp, for the thing about messaging, I think you were saying also is just like the throughput. So like in their case, they weren't even able to use Kafka for the 100%. So they had to make their own like thing to just spool data down. And then instead of doing a connected trace service, they would just do query on late querying for those repositories across all the availability zones. And I think the problem with that is just like, yeah, I mean it's cheap in a way as long as you can control those bandwidth costs, and they were sort of like hacking Amazon's billing model. so as long as you can control something, you can do something like that.
Amazing. Thank you all so much for your time. I know that we've gone over by 10 minutes, so we really appreciate you sticking around and answering a few more of those questions. And for those of you who still have more questions or want to know more about any of these projects that we've talked about, you can get in touch with us at learn@tetrate.io. You can visit the Slack channels, and we are going to share these questions with the panelists, and we will try and get a response out there in one form or another. So thank you to everyone who attended and for submitting some really amazing questions. And Adrian, Sheng, and Jaana, thank you so much for your time this morning, evening, whatever time zone you're in, for for giving us a little over an hour to be able to have such an amazing conversation. So really, really appreciate it.
Thank you so much.
Thank you.
Thank you.
Thank you. We really appreciate how involved you are in the community. It comes across. And obviously, for those of you who are here, join the communities, participate, become part of this. So you can be part of these amazing conversations as well. So thank you. And with that, we hope you have a really great evening and afternoon.
Thank you. Bye.
Bye. Thank you.
Thank you. Bye.
Bye.